Unit 8, Day 7, Areas of Regular Polygons. So first we want to look at the formula for an area of equilateral triangle. The formula is A equals 1/4 times the square root of 3 times s squared. Now I know that looks complicated, but remember, an equilateral triangle means that all the sides are congruent, so we have s to represent the side lengths. Now, we're just going to prove why this formula works. So we're just walking through it. This isn't a formal proof like the ones we write in class, but let's take a look. The formula for an area of a triangle is just 1/2 base times height. Now what I want to do is I want to take a look at this equilateral triangle, and then we're going to find the base and the height. The base is just this s. So when we substitute in, base is s. So we actually need to find the height, which is going to be the altitude. So let's bring in our perpendicular segment here to get our altitude, and then we'll begin our calculations for that. Now remember, an equilateral triangle has 60-degree angles. So this is 60 degrees, and that means that in this triangle this is 30 degrees. So we have our 30, 60, 90 triangle. So let's use our ratios to find the side lengths. The hypotenuse is s. In order to get the short leg, we want to divide by 2. So s divided by 2 gives us this short leg. And then to find the long leg, we need to multiply the short leg by the square root of 3. So s times the square root of 3 divided by 2 is the height, our altitude. So we're going to substitute that in, s times the square root of 3 divided by 2. And then we just want to multiply and simplify this out. So we have s times s to give us s squared. We have a root 3 on the top, and in the denominator 2 times 2 to put it all over 4. So if we just pull out that fraction, 1/4, and then we just switch the order here, 1/4 times the square root of 3 times s squared, and there's our formula that we started with for the equilateral triangle. So let's go ahead and use that formula to find the area of these two equilateral triangles. So area is equal to 1/4 times the square root of 3 times s squared. Now make sure this s squared is not under the radical. That is separate. Okay. So the only thing that we need is the measurement of the side, which is 2. And then when you put this in your calculator, you should get an answer. Area is 1.7 units squared. Go ahead and pause, find the area of this triangle, and then come back and check with me to see if you got it right. Hopefully you found that the area of this triangle is 15.6 units squared. If you didn't, it probably was some calculator work when you were putting this into the calculator. Make sure you carefully go step by step when you're putting all of this into the calculator. Next, let's look at these problems. So here, it tells us the area of the shaded region, and then it wants us to find the area of the regular polygon. So the first thing we want to take a look at is this triangle that we're given the area of, and consider how many of these triangles are in the regular polygon. So if you connect that center to each of the vertices, we'll find that we actually have 5 of those shaded triangles. So what we want to do is take that area of 8.5 centimeters squared, and we want to multiply it by 5 to get a total of 42.5 centimeters squared. So that's the area of the entire regular pentagon. Go ahead and pause, find the area of this regular octagon, and then come back and check your answer with me. So hopefully you counted 8 triangles and took 10.8 times 8 to get a total of 86.4 centimeters squared. The next thing we want to look at is the formula for the area of a regular polygon. Now, there are 2 ways you can think of it. A equals 1/2 the apothem times P, the perimeter, or A equals 1/2 ANS. I think if you remember this one, it'll just be more helpful overall. Now, like I said, A in that formula refers to the apothem, and that's the distance from the center to any side of the polygon, okay? It is really important that you remember that the apothem goes from center to the side. We actually have a different name for the center to the vertex. This is called the radius. We're not going to use that measurement in this formula, but this is called the radius. The apothem goes from center to side. N, as always, stands for the number of sides, and S refers to the length of the side. So if I label the S here for the length of the side, I want you to take a look at this carefully. Think back to the two sets of examples and problems that we've already done. The first set was how to find the area of an equilateral triangle. Second was how to find the area of a regular polygon given the area of one triangle. So that's the idea of what we're going to do. A triangle, remember the formula for area of a triangle is 1/2 base times height. So here, 1/2, the base, S, times the height, the apothem. So we have 1/2 A times S, and then N for the number of sides tells us how many of those triangles we have. So this is actually exactly what we did on the page before. We just have to find the area of this triangle first. So let's take a look at a few examples. Here's the first one. So we want to start off with our formula. A is equal to 1/2 ANS. So we want to make sure we find A, we want to find N, and we want to find S. Our apothem goes from center to side of the polygon. So our apothem is 4. N stands for the number of sides, which is 4. So the only thing we're missing is S, the side length. So let's take a look at how to find the side. We have this square, and then what you need to know is that whatever the angle measurement is, that gets bisected by this radius. So if this is 90 degrees, that means this angle is going to be 45. If this is 45, we actually have a 45, 45, 90 triangle. And in that, you know that the two legs are congruent. So this leg is going to be 4. And then this apothem actually bisects the side. So this is also 4, giving us a total side length of 8. So when we take all these measurements and plug it into our formula, 1/2 times 4 times 4 times 8, we get a total of 64 units squared as a final answer. Now let's take a look at this one. Here, we also want to start off with that same formula. This is going to get us to our final answer. Area is equal to 1/2 ANS. So we need to make sure we find A, find N, and find S. N, number of sides, we have is 6. The apothem, we actually don't know, and the side length, we don't know. So we need to find those. So let's take a look here. We need to go from center to the side to create that right triangle. So what I'm going to do is I'm just going to pull out that triangle and make it a little bigger over here. So here we have that right triangle. That radius, this length is 4. And then we need to find the measure of this angle, which is half of one of the interior angle measures. So the first thing we want to do is take n minus 2 times 180 divided by n to give us the measure of one interior angle of this regular hexagon. So number of sides is 6. 6 minus 2 times 180 divided by 6 gives us 120 degrees. So if this interior angle is 120, and we said this is going to be bisected, this angle measure is actually 60 degrees. So if this is 60, we know that this is 30 degrees. So we have our 30, 60, 90 triangle. And then if we want to find the side lengths, take the hypotenuse, divide by 2 to get the short leg, and then you want to multiply by the square root of 3 to get the long leg. So now we have the apothem, this distance, is 2 times the square root of 3. The side length, we said this, we found to be 2, and we said that's half. So our side is 4. And when we substitute in our values, we get a is equal to 1/2 times 2 times the square root of 3. N is 6 and S is 4. So we get an area of 41.6 units squared. In this last one, it's going to require a little bit more work, but we're taking the same idea as we did before. Our final answer we're going to get from a equals 1/2 a and s. And we need to find a, we need to find n, and we need to find s. Now in this one we have the triangle drawn out for you. So first thing we need to do, the number of sides is 8, and then we need to find everything else. So we need to find the measure of one interior angle. So we're going to use n minus 2 times 180 divided by n to give that measurement. N is 8, so 8 minus 2 times 180 divided by 8, and we get each angle inside this regular octagon is 135 degrees. Now I want to pull out that triangle. So we have our radius, that's 12, and then this angle needs to be half of 135 degrees. That's going to be 67.5 degrees. Now, 67.5 is not one of our special angles, and so we're actually going to have to use trig to find the missing measurements. We need to find A for the apothem, and we're also going to need to find, I'm going to label it x, because x is actually only half of the entire side length. So let's solve for one at a time using trig. Remember, from the angle's perspective, this is the opposite side, and we're going to use the hypotenuse. So we have sine of 67.5 is equal to the opposite over the hypotenuse. Multiply both sides by 12, and then you should get 11.1 is your apothem. Then, when we solve for half of the side length, we want to use the adjacent side and the hypotenuse. So we have cosine of 67.5 equal to x over 12, multiply both sides by 12, and then we get x is equal to 4.6. Now remember, x is only half of the side length, so we're going to need to take 4.6 and then multiply it by 2 in order to get the side length. So our side length is actually going to be 9.2. So lastly, we want to take all of that information and then plug it in to our formula. 11.1 is the apothem, n is 8, and our side length is 9.2. And when you multiply all of that, you'll get 408.5 units squared. So that's it for today, but this is pulling in a lot of things that we talked about in Unit 7, our special right triangles and our trig. So I'll see you in class, and we'll do a lot of practice with this.